I might go ahead and get started because it might be a little bit tight, but I think a few people come on in as we go. So my name is Cabell. I'm a developer at a local company called QxMD. We're working to improve knowledge translation in medicine. But I am here today to talk about Node, Kubernetes, and this idea of the lift and shift. And one thing we're going to try to do, try being a key word there, is we are, during this 30 minutes, going to try to actually get 3 clusters up and running, one on AWS, one on Google Cloud, one on Azure, and actually get a Node app with MySQL and Redis up and running on all 3 of those in 30 minutes. We'll see how that goes. While we're waiting for that to happen, we can talk a little bit about Node and Kubernetes. In order to talk about how we've gotten to Kubernetes being supported as a managed service on the cloud, we're going to talk about this vendor-consumer marketplace cycle. And this is totally something I just made up. This is not from like an economics textbook or something like that, but it's going to help us get there. So if we start at the top, there's some disruption. So some new technology comes out. And we pretty quickly move into a phase of vendor lock-in. So this is where the vendor and the specific implementations of the vendor are going to dictate the behaviors of the consumer and make it more difficult for the consumer to be flexible. So then, after some time, the market catches up, and we move into this adapter phase, where as long as the consumer has access to the right adapter, the consumer can start to make some decisions on their own, have some flexibility, and then plug into that adapter. That adapter handles the specific implementation of the vendor. And then finally, we move into this standards phase, where the consumer can make sure they're okay with the standard, and they can trust that the vendor is going to support that standard. So think about this in a little bit more detail. We can go through an example. So if we roll it back to 2015, and we are shopping for headphones, and we find these sweet 55-cent headphones online. They've got this 3.5 millimeter headphone jack, and in 2015, that's a standard. We can trust that our 55-cent headphones are going to work on our current phone. We expect them to work on our future phone, our friend's phone. We're good to go. But all of a sudden, in 2016, Apple decides to leave that 3.5 millimeter headphone jack off of the iPhone 7. And all of a sudden, we moved into this phase of vendor lock-in, where the vendor is dictating our decisions and our behavior. And we have to think about, when we're shopping for headphones, what the specific implementation of the vendor is, so that we can find some headphones that work with our current phone, are going to work with our future phone, going to work on our friend's phone, whatever. So we have to think a little bit more. We're a little less flexible. And Apple is very happy to quickly move us into the adapter phase. And they are happy to sell us an adapter so that we can go back to making whatever headphone decision we want. And as long as we have this adapter, we can buy those 55-cent headphones. We're good to go. And it turns out that Apple is pretty good at this. They're happy to sell us lots of adapters, and they are good with the adapter phase. But eventually, the marketplace catches up. We can buy an adapter, and then we can look for 55-cent headphones. If we want to buy those $30 Lightning headphones, we can do that. We're good to go. So I'm going to argue or say that we've had something similar happen in terms of cloud providers and being able to run our resources in the cloud. Hopefully, we're going to get to where we can say now we've reached a standards phase for running our resources in the cloud, and Docker and Kubernetes are what have gotten us there. So if we start at the beginning, at our disruption, our new technology, AWS sort of becomes generally available, and shortly after, we have Google Cloud and Azure follow. And at this point in time, we're in a lock-in phase. When we're going to put our resources on the cloud, it's really important what our initial decision is, because we're going to start really quickly managing our resources according to the specific implementation of the provider we choose. Then it gets really difficult to untangle all that and move to another provider. In addition to just that specific implementation, these things that are difficult about running our resources in general, but also on the cloud, stability, scalability, efficiency, those things are parts of infrastructure that are not easy. And so we start to plug into these managed services where a lot of that hard work has been done for us. But as we plug in, it gets harder to untangle all those plugins, harder to say, okay, we're not happy with our current service we're being provided, so we're going to take our business over here. That gets much, much harder to do. But moving forward, we slowly move into an adapter phase. We have some options later on for like Terraform, where we can define our resources within this like abstraction layer and have some centralized configuration for our resources and utilize Terraform as the adapter to make sure whatever cloud provider we're utilizing, we can provision those resources as we want them repeatably without issue. So we move into this adapter phase, and just as a sidebar, at the same time, we start to have container technology sort of picking up steam, and the Docker project gets started, and there's sort of this competition for container technology. And shortly after, we realize we need to orchestrate these containers, or the general public starts to think about orchestrating these containers. The Kubernetes project starts up with a bunch of others, and there's sort of this race to become the standard in container orchestration. And so we move on to 2015, and Google Cloud makes Google Container Engine for Kubernetes available generally. And at this time, Docker and Kubernetes are sort of starting to win out in their domains in some ways, and this definitely helps Kubernetes. And that starts to move us into a standards phase where we can trust the standard of Kubernetes and rely on that vendors are going to support that standard. And so in the last year, we've finally gotten there. We now, for the three major providers, we had Google Cloud first, and now we have Azure and AWS with EKS are now all three supporting managed Kubernetes. And so we're at the point now where Kubernetes can be treated as a standard. As long as we are supporting this standard of Kubernetes to define our resources locally, we can trust that the vendor is going to support that standard as well. And so that's my first takeaway here, is that we've now entered a standard phase of providing our resources in the cloud. And Kubernetes has given us the opportunity to do that, and given us the opportunity to have some flexibility in terms of which providers we use. And now, theoretically, take note of the asterisk there, the lift and shift is possible. So what is the lift and shift? So the lift and shift is this idea of taking all of your resources that are running on one provider associated with a project or an application, lifting them up, shifting them over to another provider, setting them down, and being ready to run. And the idea that this can happen relatively easily. And so in particular, why should the Node community care about Kubernetes, lift and shift, all this infrastructure stuff? Why does it matter? And to think about that, I think we can go to, we can think about what are the things Node is good at, and what are the things that Node is good for. So Node is developer efficient. It is fast to build with Node, fast to get started, and along with that, it's low barrier to entry. It's low barrier to get started for developers. It's low barrier to get something up and running. And finally, it's really good at I/O-intensive work. It's asynchronous, and it's well suited for waiting on other services to do things. And so that, I would argue, is probably, it makes it a good choice for most of the workloads out there. I mean, a lot of the work is just going to be waiting on something else to do some work. So those three parts of Node that are quite good lead us to the projects or the teams that Node is good for. So I would say Node is particularly well suited for small teams where developers are wearing multiple hats, doing some front-end work, doing some back-end work, doing some infrastructure work. Node is well suited for prototyping, for saying, I want to validate this idea, so I'm going to build something as quickly as possible just to get it out there. And so having that low barrier to entry, that developer efficiency, makes it well suited for prototyping. And finally, it's quite well suited for services and service-oriented architecture because it's, well, low barrier to entry and dev efficiency help with that, but also it's really good at I/O-intensive work. And so if you have a bunch of services that are working together, they're all going to be waiting on each other a lot. I would argue that those are the teams and the projects in terms of small teams, in terms of prototyping projects that might benefit the most from having flexibility in terms of cloud providers and having and avoiding vendor lock-in in some ways. And that's not to say that this is like we're all good to go now. I think that vendor lock-in is still alive and well. And if we look at the deals that are available to get started on AWS, on Azure, on Google Cloud, to me, it's pretty clear that there's still some value for vendors to try to get consumers in the door, and that there is still going to be difficulty in unplugging and moving, and value for the vendors in getting someone there. Which is not a bad thing for consumers. I think that's something we can take advantage of. And so I'd say the more mature an application is, the more difficult it's going to be to move. As the application matures, we're going to plug into managed services. We're going to work more towards the specific implementations of that provider, and it's going to be harder to untangle all that and move it over. So should you just leave now? Should we all go take a nap or something? And I'd say hopefully not, that there are some use cases still for taking advantage of this flexibility that Kubernetes as a standard gives us, and the ability to lift and shift even if it's for a limited time. And so one of those use cases is prototyping to compare. So this idea, if you're starting a new project, if you're starting a new application, with Kubernetes as a standard and managed Kubernetes available, I think you can feel comfortable testing out developer experience on a new provider that you haven't tried before, testing out the service offerings on one provider, or testing out two at once and comparing them, evaluating costs on various providers, without feeling like you are doing something specific to that provider, and so you're creating more work for yourself if you need to move again later. So for a period of time, you can say, I'm going to define my resources with Kubernetes. I'm going to try out Google Cloud, and you can, in a relatively short period of time, hopefully we can prove that in less than a half hour, you can just move over to another provider. And so I think this is very reasonable right up until you start to scale right now. And that's when you really start to need to plug into services as is. So yeah, prototyping to compare is one of those use cases. Another is attempting to use the right provider for the job. So we talk a lot about in languages. Some languages are better at some things, others are better at other things. So trying to use the right tool for the job, I think we can also apply that to cloud providers. So some cloud providers are going to be better at providing some managed services than others. So you can utilize Kubernetes to organize your resources in a manageable way, even if you're deploying to multiple providers, and taking advantage of, if Google Cloud's got really good machine learning services you want to take advantage of and you want your resources to be close to that, then you should feel comfortable deploying to Google Cloud and not feel like all of your other resources have to go onto Google Cloud. You can sort of move resources around and not have a total mess. And finally, this is something we've dealt with at QxMD, is you have an opportunity now to try to avoid legacy lock-in. So if you have some resources that a long time ago were put on EC2 instances on AWS, you're totally plugged in there. There's no way that legacy project is ever going to go anywhere else. Now, you can reasonably say, I'm going to, for this new service, organize my resources with Kubernetes, deploy them to Google Cloud, and at least assess whether these services over here on AWS need to have lower latency than I can deal with, having them on separate providers, and feel comfortable that I could move these new services back over to AWS without much work pretty quickly. So it gives you a chance to think about having this multi-cloud setup and avoiding having to stick with one provider because initially you have some legacy code that's locked into that provider. So that's my second key takeaway, is that this Kubernetes as a standard and the availability of managed Kubernetes gives you some flexibility, at least gives you a little more runway to feel like you can move resources around between different providers and not feel like you're creating extra work for yourself, creating tons of confusion. So I'm going to spend the rest of my time talking about or trying to convince you that you don't have to do it the hard way, that Kubernetes is relatively complicated, but we don't need to know all of the internal details, especially now that Kubernetes is a standard, to take advantage of the flexibility the standard provides. Because Kubernetes is provided as a managed service now, a lot of the hard work has already been done. So there's an opportunity to take advantage of the flexibility, try things out, try to stay flexible, come back and learn about all the details later on. And so I might check on, I have, right before we got started, I used Terraform, and we got 3 clusters up and running. So the one on the left is a cluster that just started on Azure. In the middle is a cluster on AWS EKS, and the one on the right is Google Cloud. And so I'm going to try on this other computer here to actually get some Node apps up and running. So I have some notes which should make it a little faster for me. So this idea, if we have this Node app and we can deploy to all three at the same time, then hopefully that's proof that we could lift and shift our application one at a time. On the left, once we have our cluster, we just have to point our kubectl context at that cluster, which we've just done, and we should be able to see a Kubernetes master service up and available on Azure. So that's a good thing, and maybe I'll make this bigger so we can actually see what's going on. So if we try to quickly move over to this Node app we have, and I'll just quickly, so the Node app is literally just an Express app that's as small as it can get. It has one endpoint that tries to make sure we're connected to MySQL and Redis services that are available in that cluster, and we should be good to go. So if we go where we have our Kubernetes configuration or specs for that app, we should be able to kubectl apply. Let's make sure. Cool. So we'll see on Azure whether we can. So on Azure, we've deployed this Node app. We've deployed MySQL data store and associated service, and a Redis in-memory store. So if we look at those services, if I can spell things. Then we should be able to see we're trying, so when we create a service for the Node app, we've got to wait a minute because Azure is going to make sure we have an ingress or load balancer set up for us, and we have an external IP address so we can actually look at our Node app. So hopefully in a minute, we'll actually have a Node app up and running on Azure, and then we can move over to Amazon EKS and try that one and see where we get. So the goal of trying to get those three up is to point out that in less than 30 minutes, we can get 3 clusters up and running. We can deploy 3 basic Node apps and have all of the things that come with Kubernetes. So one of the things that helps us do that, if we're, I guess this is arguably not doing Kubernetes the hard way, is we can use Terraform as the adapter for the specific implementation of managed Kubernetes for each provider. So once we've created a cluster based on that specific implementation of managed Kubernetes, then we're at our standard. Like, we should be able to kubectl apply that same app, just point it at whichever cluster we want to, and our app is up and running. So we can use Terraform to get those resources up. We can see that on Google Cloud, it's 1 resource to get a cluster up and running, which is pretty easy. On AWS right now, it's 23 resources to get up and running. But if we utilize Terraform, we can define that once. We can Terraform apply, and we should be good to go no matter what. And since these are pretty young managed services, I think we can feel confident that these, especially on AWS, that these numbers are only going to go down. These are pretty new services. So the barrier to entry for utilizing this managed service is only going to get lower and lower. So once we have that Terraform adapter layer, we should be able to Terraform apply for Google Cloud, for AWS, for Azure, and have 3 clusters up and running, which is what we did when we sort of started over here. So so it should be easy to get those 3 clusters up and running. And then we only need to regardless of which provider we're thinking about using, define Kubernetes specification YAML files, configuration files for whatever resources we need. We have our Node app that's ready to go, and we don't need to do anything else specific to the provider. Those providers should support the standard, and we should be able to point our context like we just did at Azure first. We ran kubectl apply, and our services are available. We're waiting for an external IP address. We're then, in just a second, going to point at AWS, EKS. We're going to run kubectl apply, and we're going to have the exact same thing up on EKS without making any changes to those resources. And then we're going to try to do it to Google Cloud if we don't run out of time. So if we look, if I get everything organized here. So if we look at our service that's on EKS, we now have an external IP address, and that load balancer takes, or that ingress takes a little bit of time to get up and running, but we should be able to go to that external IP and eventually, hey, there it is. It's up and running, right? So we got one Node app up, at least in 30 minutes. So we can try to see if we can get the other two up in time. So here, we should be able to just make sure we get the right credentials for EKS, for our Kubernetes cluster that we created there. So we should be good. We added a new context. And then we should, if we kubectl get all, we should see that our Kubernetes master on EKS is up and running, and it's good. So that's great. So now we have one extra step for EKS. Part of that 23 resources is that we are basically sort of bootstrapping things ourselves on EKS still. So we actually have to, other than the control plane, we actually create, for a 2-node cluster, we create 2 EC2 instances, and then what we're doing right now is basically telling that Kubernetes control plane, grab these 2 EC2 instances and make sure they're part of the cluster, because otherwise we have a cluster with no machines, and that's not very useful. So it takes like 30 seconds, hopefully, and we'll have those 2 machines. We can kubectl apply our app, and we're good to go. And then we'll see if we have time for Google Cloud. If we, it's ready to go, so we will just see if we can get a, So we'll go over to the app, which is what we did before, which is our Node app. We can just run kubectl apply, this configuration, and the same thing is going to happen, right? The same thing we did on Azure. We have our app service, app deployment, MySQL deployment, Redis deployment, all good to go. And then we can just try to get that external endpoint, and we will have at least gotten 2 apps up and running, which maybe that's a win. So after a little while, EKS or AWS is going to create a load balancer for us as well. So it may not come up immediately, but in a little while, that will be ready to go. And if we can get through it, we'll try Google Cloud. If not, I'll have failed. Just to finish up, now that we're up, now that we've gotten our Node app up and running, at least right now it's on Azure, it's on AWS, not only do we have all of that, but we have the scalability, the efficiency, the availability that comes built into Kubernetes. We have no downtime deployments, we have easy rollouts, rollbacks, we have self-healing, service discovery, all of that which comes with Kubernetes. And so the goal or the hope here from this last part is that you can feel comfortable trying out Kubernetes, trying out these managed services the easy way. Utilize Terraform as an adapter to get to hook into the specifics of the implementations for managed Kubernetes, various services. Utilize something like Docker Hub for a general container registry. And once you get going, projects within the Kubernetes ecosystem like Helm, which help you easily get some more complicated multi-service resources up and running, give you a chance to have a longer runway to be able to lift up your application, shift it over, and be a little more flexible as a consumer in terms of vendor of cloud providers. So yeah, that's the last takeaway. It's okay to start the easy way. In 30 minutes, we got clusters up on 2 separate cloud providers and Node apps running on those two providers. Let's see the last piece. If this is up, then we would be good, but it's not. So we at least got 3 clusters up and running. We got 1 app running, and I think in 40 minutes you can get 3 clusters up, 3 apps running, have all your Kubernetes available to you. So I actually have the code that gets 3 clusters up and running theoretically, and gets 3 Node apps up and running on separate providers. It's going to be up shortly after this on GitHub, and I'm happy to answer any questions or anything like that. Thanks for listening.